Thanks, everyone. It is a pleasure to be here. I'm going to start with two confessions. The first confession is, if you are a keen observer, you'll notice I lied with the title for this talk. If you look here, we've got a regular sized bottle, but down here, that isn't actually a long neck. That's a pint-sized bottle. But for the purposes of, like, writing things off as a tax expense, I will buy beer. I do enjoy drinking. The second thing is, because this is the Kiwi-free track, I will insert my own little fact about Australia. Do we have anyone from Queensland in the room? Queensland represent? Okay. One little fact about people from Queensland is in Australia we call them banana benders. And why is this, you might ask? Well, as it turns out, all of Australia's bananas do in fact come from Queensland. But when they grow on the tree, they're actually dead straight. And it's only in the harvesting process do the Queenslanders put a little bend in them, and hence we call Queenslanders banana benders. I honestly did not know that. So anyway, my name is Geoffrey. I do programming sorts of things at a company up the road called realestate.com.au. We're based over in Richmond, just up the tail end of Victoria Street. I've been there for a bit over 5 years now, a little bit of a time. Now, not everyone is looking for a house all the time, so some of you may not have used our website recently, but we have actually been around for quite a fair bit of time. I think the site first started in about '96, running out of someone's garage in some place. So you can see here, we predate such modern web technologies such as rounded corners, white backgrounds, nice looking fonts, that sort of stuff. I'm kind of hoping maybe in about 5 years' time the vintage web look will come back in, and we can just do the world's largest git revert, and get back to a much nicer, older version of the site. Now, because we've been around for so long, there are some skeletons in the closet. We've got so over time, we've built a lot of little products that hang off the side, and then maybe some of those products wind down, but they still make a bit of money, so you have to keep them running. We have to build and maintain a lot of different bits and pieces. But the good news for you is that we're actually, we're pretty skilled at keeping control of this motley lot, and we've had to learn how to sort of tweak and tune all of these little parts that make up a combined sort of user experience, and we've got some idea about how you go about getting good performance out of them. So what does a bottleneck look like? And I know we've seen a picture of one, but bear with me. So up here, I've got a snippet of code I've ruined from PDFkit. There's a RubyGem called PDFkit. This is actually from one of our reporting applications. It's a bit of rack middleware that basically gets tacked on to the end of a request. And what it does, it essentially, you get a request coming through, it renders a bit of HTML, and then this bit of code sits at the end and goes, oh, that looks like something I could turn into a PDF. And you can see here in the middle we've got some highly advanced regex HTML parsing, and then right in the middle here we run this lovely program called WebKit HTML to PDF. And that basically takes our HTML, grabs all the JavaScript, grabs all the images, and renders it, rasterizes it, turns into a PDF, and spits it out in the response body. If you're also keen-eyed, you can see it does some really nasty things to its HTTP headers. So running this once or twice, maybe it's not that bad a deal, but if you're in some giant loop, hitting a web server, getting PDFs, say you're doing a mass email campaign out to people, all of a sudden, this can get quite acutely painful. Your WebKit, being the main word there, it's you're spinning up a browser 10,000 times, rendering one page and shutting it down again. That's pretty bad. But thankfully, this is a type of bottleneck, we can get around reasonably easily because the bottleneck is sort of essentially confined to sort of one server or one application process. We can just simply run like, a giant pool of them, run this in parallel, and, that gets around it. Another kind of bottleneck we've seen previously is the classic I/O bottleneck. This is a graph generated by Munin. Munin is one of those great little programs you can just throw on a server, generates a giant pile of statistics about all kinds of stuff, sticks it somewhere, and you can generate pretty graphs. Now, as you can see here, so this is a database server we're looking at, and as you can see on the left, we've got the load goes up to 800%, so we've got something here with 8 cores. You can see normally this server, it's running some sort of, is that turquoise? Anyone with UI in the room? So normally turquoise means the server's bone idle, and then down the bottom we've got this sort of these blue blips which are the server sort of doing something. But up in the top right here we've got this horrible sort of pink hue that's sort of creeping down and making the graph look pretty ugly. And what that is I/O wait. So instead of being bone idle, the server's being bone idle waiting for the disk to do something. Now if this were like a one-off spike, we wouldn't be too concerned. But if you look down the bottom of the graph, these are week-long sort of spans of time. And what this means is, well, like in America, they've got the fiscal cliff where you sort of drive off and your economy stops or something. Well, we've sort of driven off an I/O cliff here. The server basically is now hamstrung by the fact that we're just putting enough writes and reads into it that it can't actually sustain that load. And so everything that talks to this database server now starts to run a bit slower. Now maybe if we had loads of spare time and loads of really smart people, we could write some sort of crazy database sharding program and run across multiple servers. But we don't. We're pretty cheap, so we just upgrade the server it's running on. This sort of problem is something we do keep an eye on to this day. You can see here this is actually a pretty old graph from 2010. But this is a pretty key metric for our databases, so it's one we still pay attention to. Now, I would like to point out that bottlenecks don't necessarily have to be a bad thing. Sometimes we can put in an artificial bottleneck into a feature as kind of to make our lives a bit easier. So this is the sign-in for the back end of realestate.com.au. That's one thing people like. It's a good-looking back end. We can see here, I've, logged in too many times and, it's basically locked me out of account for 15 minutes. Now, in theory, we run an Australian listing website. And so you think it'd be really popular in Australia. Well, as it turns out, Agent Admin is a very popular website in Romania. Really big hit. And the Romanians just love looking at our, you can't log in screen. And so to make sure, they can look at our can't log in screen, just to make sure in case they accidentally get the password right, we make it so if they get the password wrong, 3 to 5 times in a row, they can't log in for another 15 minutes. And, it does help things in that thing. So those are 3 different sort of bottlenecks. And one thing about applications is all applications do have some sort of bottleneck somewhere. You may not be able to see it at all times. Sometimes, they're not easy to find. And if you do find it and you remove it, you're not getting a bottleneck-free application. You're just exposing the next bottleneck that was hiding underneath that one. But the thing is, as in the previous examples, if we understand our applications, if we understand sort of what their performance characteristics are, we can actually engineer around these bottlenecks. So, how do we find bottlenecks? Well, it'd be pretty cool if we had some sort of magical testing wand we could, whiz around, pull in our application and go, there's the problem. But unfortunately, no such thing exists. Now, I know what you're thinking, I run Rails, I can just, generate a performance test, run it against my application, and everything will be hunky-dory. It'll point out my problem, and that's sort of, yes, you can do that, Don't get me wrong, Rails performance tests are nice in that they're very easy to sort of create, very easy to set up. But, you know, if your application was really simple, maybe that'd sort of help you find stuff. The problem with Rails performance testing is that it's centered around performance testing what you're developing on, like your laptop. And it also tends to assume that the bottleneck is going to be something that's going to be inside your Ruby process and in your development environment, obviously. So if your application is nice and simple, you know, maybe that'll work pretty well. Usually applications are not that simple. You know, you're not talking to one database, you're talking to several databases, you're talking to some in-memory database, you've got some APIs you're calling. There's a lot of complex user interactions that go into making up a basic sort of web page render. And so as a result, to find performance issues, performance bottlenecks in our application, we need to be a bit more rigorous with our testing. Now, performance testing is kind of similar to testing like a car. Sometimes, you know, we have a specific performance goal we want to go and hit, and so, you know, we'll go out, we'll sort of, you know, race around lap after lap after lap. We change a few things. You know, we say, okay, you know, are we there yet? No. Are we there yet? No. Are we there yet? Yes. Woohoo! Other times we just want to like kick the tires and see how it feels. Performance is not really performance is like a relative measurement. It's pretty hard to sort of, you can say, oh, something's absolutely fast, but usually in most cases what you're really after is this sort of fast enough for what I need. Probably a really good example I can think of in that case is if you ever sort of meet an iOS developer and you're showing them off, like, you know, some great iOS app you use, you're flicking around going, oh, you know, this looks great, and then you show it to them and they go, oh my god, that's a disaster. You know, that scroll thing is like, you know, skipping one frame in every 4 or something. You're like, oh, looks fine to me. I know Charles says Ruby is slow, but I like to think with Ruby, like, you know, you're driving with style. Now, performance testing is hard. It's not something you do every day, I don't think. It's only something you do in response to, you know, if you're making like a really large change to your application, it's up to you to sort of decide if you're doing something, if this is going to make a performance impact or not. Sometimes, maybe depending on like what kind of website you use, if it's on like a life or death thing, you can always just launch it, let your users find out for you. It does help if you have good relations with your users in that case, or a nice 500 page. And an also key part of that is, you know, if you do launch something and it breaks, maybe, you know, it's really cool if you can say roll it back really quickly and go whoops, or, you know, if you can fix it really fast, that also works well. People like to be sort of involved in the story there. So a key part of performance testing is generating load. It's pretty hard to figure out what a system's doing when it's bone idle. So I'm just going to talk about some of the tools we use at REA for generating load on systems. One of our little favourites is a tool called Siege. Siege is a great little tool. It's really easy to set up. You just brew install Siege. You can get it running on your OS X laptop. It's easy to script. You basically just run it, call it on a list of URLs. You can pass in the time window you want it to run for, a concurrency thing, and it will just bash away and return you some good handy measurements there. Because it takes a list of URLs, it's really easy to script. Now, with the caveats for this, it's obviously not a browser, so you're not testing your JavaScript, you're not really testing sort of the static assets of your website. And because it's also, there's no concept of like cookies or sessions in it, so you can't test sort of a more natural sort of user interaction with your site. But one case we do use Siege might be if you record like an access log pattern on like a particular server, you could then sort of hack that up with some scripting, replay it through Siege, and try and generate something that's a reasonable facsimile of user load. One tool we do use extensively is this great, fantastic Java app called JMeter. JMeter can load test HTTP applications. It can also load test SOAP, LDAP, and Mail, and a whole pile of stuff. Like Siege, it's pretty easy to set up. You can brew install it again. JMeter is a bit different in that you essentially use JMeter. You can create test plans in it, which you then save. It's still as fairly opaque XML, unfortunately, but being text, you know, at least you can stick them in version control. It is one of the worst UIs I've ever used. That's pretty awesome, I think. And basically, with JMeter, we've got a bit of a test plan from our front end here. You just run that. It will churn through and spit you a giant CSV file with response times and latency. It's still not quite a browser, but you do get better sort of session handling through it. So we are sort of it does represent a sort of more user-aligned sort of testing thing. But thankfully, if you're not using JMeter yet, I would say just completely ignore it, because a really recent thing on the thing is GridInit. I first learned about GridInit at one of the Rails camps. It's developed, I think, here in Australia. And it's a really nice Ruby DSL for writing JMeter JMX files. I think something like the penultimate form of any Ruby library is a DSL. It's sort of the ultimate form the Ruby thing can be. It's really nice, it's really simple. So you can see here we just start a test, visit the Google search page. We can actually assert it contains things, you can pull information out and use that to sort of drive further steps in the page. And you can, it's just so much more readable than the classic JMeter JMX. And last but not least, if you went to Keith and Mario's talk, you would have noticed them talk about web page test. Web page test is a fantastic tool. If you're not using it, you should. Web page test is simply like, you can think of it as like a catalog of browsers with specific versions and in locations. The example here I've got, I think that was IE8 running out of Singapore. But you can actually, with web page test, it is sort of open source software. You can actually download it if you're working somewhere, or maybe where you don't want to do a performance test on a live thing. You can actually download it and run your own completely local setup. They've even got pre-built EC2 AMIs, so you can run it, sort of spin up stuff in the cloud. Basically, yeah, web page test gives you loads of stats. This is like the first view from, I think, yeah, that was IE8. Yeah, I can't say enough about web page test. So let's assume you use some of these tools to generate load. Another thing, so after you've generated load, you've got some usage material, but how do you make sense of it all? The second half of doing performance testing is monitoring. After you do a performance test, you sort of need to be able to look at your, if you didn't hit your performance target, you want to be able to drill down into what happened to see sort of where things are going wrong and why your application is slow. One thing we use quite a fair bit at REA is New Relic, and New Relic, I would say, is exceptional value for money. You essentially just do gem install New Relic, stick your API key in, and bam, you get working monitoring. It works for both Ruby, Java, and PHP apps. So maybe if you're doing programming in your less liked language, it's still pretty good. The downsides are it does cost money, but the free version does keep the last 30 minutes of data. So if you're using it maybe in some sort of staging pre-production environment, you can smash that and just quickly look at the last 30 minutes and it'll help you drill down. Also, if your app is on Heroku, I think Heroku users get the standard version of New Relic for free. But if you're not on Heroku, they do charge per service, so can get a bit pricey. If you're in Amazon land, of course you want to use Amazon's CloudWatch. CloudWatch is free and it pretty much monitors every type of AWS resource that's out there. The free monitoring interval is 5 minutes. You can pay a bit more to get fine-grained monitoring. CloudWatch is a bit opaque in that sort of you get a lot of stats, but it's sort of hard to gather them together and combine them into something that's really useful. And for doing things like that, you'll probably want to use my next favorite tool, which is Graphite. Graphite is freaking awesome. Graphite is essentially a database for storing a time series of numeric data. I'd say Graphite would be the equivalent of like the Excel of the monitoring world. If you get data into Graphite, it's very easy to sort of combine it with other data in Graphite and produce pretty graphs like the one we can see here. This is sort of an average of active passenger instances on one of our Ruby application farms across a rolling 5-minute window. Graphite doesn't actually collect any data by itself. It's essentially like a RESTful sort of data store. So you'll need something like Munin, which we discussed earlier, or CloudWatch to collect metrics and then gather them and run them into Graphite. Another local Melbourne shop, 99 Designs, actually have written a really handy bit of software called Vacuumetrics, which you can use for vacuuming metrics out of other systems such as New Relic and CloudWatch and ramming them into Graphite. The final bit of the puzzle is log aggregation. If you're sort of hitting your servers and you're showing errors, normally hopefully your applications are logging like stack traces and errors out to a thing, to like a file locally on the server. And if you've got multiple servers, it's really handy to have like another tool you can use to sort of combine those and look at them in a sort of in a time-aligned fashion. If Graphite is a time series database of numeric data, you can think of tools like Splunk as a time series database for strings. Splunk is sort of a rather fat application which you can sort of lob in, and then you run mini Splunk instances of a whole bunch of servers to forward your logs to that main Splunk server. If you don't want to use Splunk, there are some really good free alternatives for log aggregation like Greylog2, Logstash, and Kibana. All of those are a bit easier to set up than Splunk. It's a fairly obese app. But if we look at Splunk here, we can see some recent work we've been doing on, this is basically just a graph of the ingestion rates on our, some of our back-end listing XML data. So those are like tools we use when we do performance testing. Now I'm going to talk about some of the stuff we do where we sort of test for performance and sort of what are some of the outputs of that. So out of Murray and Keith's talk, we learned that sort of optimizing static assets was a pretty big deal when dealing with performance, and it's also a pretty big deal for us. This is also something we do fairly well, which is why I'm going to talk about it. A lot of what you get in a website is not necessarily your backend. Once you render HTML, the browser's got to go off and grab a whole lot of other things. If we look here, I've got two snippets from Chrome's DevTools, one being the first request for one of our sites, the other being the second request. The first request, we make a giant pile of requests, we download a whole bunch of stuff, and we can see it takes 7 seconds to file the onload event. But in the second request, with the cache warmed up, onload fires in slightly under 2 seconds, so that's a huge difference. And if we look at these sort of pie charts, those are from a web page test. You can see that for the site, like something like over about even 3/4 of the requests are for static assets like HTML, JavaScript, CSS, and it's also something in line of like 2/3 of the actual size of the stuff that we download. And so once we get, even though the site is not fantastic, we can see that with the caching, we can get some better performance. Now just HTTP caching really quickly. HTTP caching is composed of two parts, expiration and validation. Expiration is just a means of saying once an HTTP client has something, what it can do with it. So in this case, we've got a cache control header that says this cache entity, this HTTP entity is public, which means it's not tied to any user session, so it can be actually shared. If someone else comes along, they can also get the same cache entity. And we're also telling any upstream HTTP caches that they can cache it for 60 seconds. That means sort of if you're making a request to something and you say make 6 requests in a 60-second window, that means like every sort of, even though you're making a request every 10 seconds, you're only going to make one actual request back to the server in that 60-second span. The second bit of HTTP caching is validation. Now, after we've cached something, we can actually make a conditional request back to the origin server to ask, hey, I've got this stale item, is it still valid? And validation is really cool. With validation, you can basically provide a few extra bits of information about whatever it is you're requesting, which is like in this case, we have an E tag, which is just usually like something like a content hash or something like that, and when it was last modified. And I can make one of two conditional requests. to sort of ask, hey, is this cache item still valid using either of those bits of data? And the server can actually respond back going, yep, that's all cool. And I can keep using my HTTP cache, and we haven't had to actually send very much across the pipe. I mention this because yesterday we were asked, what inspires us, and I actually think the Rails code for doing HTTP conscious rendering of content is actually really, really cool. This is an example, a really simple example controller called with an action called show something. With this, we're using Rails' inbuilt action controller conditional get helpers. We're setting a cache control header at the top there. We're saying max age is going to expire in 1 day. We find an item in our database, and then there's the stale method. What stale method does is it will set the e tag and last modified headers on the HTTP response, but it will also check at the same time to see if it's getting a conditional get. And if it is a conditional get, and the get is sort of satisfied, the object has been modified since it was last received, it will actually skip over that response block and just return the correct HTTP response. And I've used a number of different sort of web frameworks and web things over the years, and that's by far the best sort of HTTP conditional get support in just about anything I've seen. The cool thing there is we're essentially, even though we're still going through our Rails pipeline, you've got an if block, so we can skip over some potentially expensive content stuff in there. So like if you're doing anything expensive in a template, or you want to find up additional relational objects, we can just skip straight over that. Now, one thing we do a lot of HTTP caching of is images and thumbnails of images. On our website, a listing can have between 1 and 26 images, and we want to provide thumbnails for those images because we run the main website, we run mobile apps, we run tablets, we've got loads of different things, and so we want to provide thumbnails for those things. When you're presenting a user review of say search results, we can generate nice pretty pictures and stick them all in. So say every listing has 26 images. Say we've got like 1 million listings, and say we want 10 thumbnails for all our different sort of use cases. That's 260 million images. That's a fair bit. And if Apple decide tomorrow to release another tablet and we need more thumbnails of different sizes, that's a lot of thumbnails to go and generate. It's a real pain in the ass. So we want to try and avoid that if possible. So what we do instead is we generate thumbnails on the fly these days. And we then cache them over HTTP, and I'll just describe a bit about how we do that. So our static image caching is done across a range of hosts. So when we render content back to a browser or a tablet, we actually spread the requests across a number of hosts. Browsers typically make about something like 2 to 8, possibly more connections per host. That means if you have like a whole pile of listings coming in, you'll be able to sort of parallelize your downloads a little bit. We then also include stuff like the size of the thumbnail we want. You can put in any arbitrary size and you'll get it. It will ruin the aspect ratio, but that's life. We are working on extending that a bit to allow for sort of cropping and borders as well. Then the main thing is the content hash. The content hash basically allows us to uniquely identify what image you're after. In theory, once someone's uploaded an image, we never actually bother to change it. It just sits there. And the last bit is, we have a file extension saying, hey, I'm a JPEG. And we also allow for a bit of text to so when you save an image, you get a nice file name, and I think there's some SEO value for that as well. So all of these images actually wind up getting stored in S3. S3 is fantastic. We love S3. I think originally, when our last sort of major site design went live, we didn't actually have enough bandwidth to serve all of the images at peak load out of it. But now, thanks to S3, we do. We originally were sort of piling stuff into US West, but recently Amazon's introduced a local facility in Sydney, which we now use to upload images. We then just run a giant pile of EC2 instances out of whatever data center the S3 buckets are in. And we've got Amazon AMI and auto-scaling there. And then, last but not least, we actually wrap the whole thing in a CDN. You don't notice you don't notice where we serve content from because we use a CDN. We actually pay a fair bit of money and use Akamai. CDNs are fantastic if you want to survive. If your website winds up being number 1 or number 2 on Reddit or something, and you want to be able to survive like the next 24 hours, just whip out the credit card and get a CDN. They're sort of pretty amazing. As an example, even though our main serving facility is in Australia, sometimes if we're doing maintenance or we need to unplug some cables there, we can flip over to our emergency DC, which is in Amsterdam, and no one notices. So CDNs get away from it. Let us get away from that a little bit. Last but not least, you can use S3 a fair bit in Rails, and it's pretty easy to set up and get going. You can use JMeter S3 when you're doing content, you're generating your compiled assets, and you can actually upload your assets in S3. So maybe even if you're running out of Heroku and you don't want to serve assets out of Heroku because it's all the way over in America, you can actually just upload those into S3 and serve them out of a S3 bucket in Sydney. There are some tools out there to let you, if your users are creating content, you can just have them either pass it through your Rails app with something like Paperclip and then upload it straight into S3. Ultimately, I think there are some JavaScript modules out there which let you upload into S3 directly from someone's browser. There's also a really great image handling utility out there called Dragonfly, which also does image resizing and caches the resulting stuff in S3. So the main thing I want everyone to get out of this is for performance, you need to measure things, you need to measure them again and again and again, and after all that, you need to cache. HTTP caching, it's fantastic. Regardless of how sort of new or old your application is, HTTP caching lets you sort of do lots of marvelous things and get away with them. Thanks. Yeah, any questions? First in the middle at the back.
Yeah. So you're presenting a lot of different services where you're storing data. Have you got ways to easily aggregate that data so you can get
So the question was regarding when we do performance testing, we have a lot of different bits and pieces, and when we finish with performance testing, how do we sort of combine them to get a combined view? Good question. Typically, we'll do other testing sort of from the front door, and so we'll be testing from a single point of view, and we'll look at we'll get performance data out of that, and then it'll either be good, in which case we don't really have to worry too much, or if we see sort of spikes or a lot of differs from say a standard deviation, we'd sort of drill in. With stuff like New Relic, that drilling in is pretty easy. And because you can just go and click on a specific request and see which one was slow, and then you can run tracing thereupon and see stuff. If you don't pay for New Relic, there are other third-party tools. I think there was a recent Railscast for a Fjord metric, which lets you do arbitrary metric gathering into something like Redis. Beyond that, yeah, it's just a question of you would then maybe, if the thing's slow and we know we've introduced some new features, it'll also be a case of just looking through the changelog and getting some idea of what we've changed recently and how that might have affected performance as well.
So anecdotal and New Relic is...
Yeah.
Okay.
I mean, at the end of the day, like we do, in theory, if you're changing a system, you should have some idea of what that impact should be. Not fantastic, but yeah. Other one?
You mentioned it's tough doing the performance testing on your laptop.
Mm-hmm.
Is it similar when you're using Siege or JMeter to get enough load to sort of get real results?
You can, if you're testing like an external environment, depending on basically if your network isn't the bottleneck between your laptop and whatever, you can just run those load testing tools locally on your laptop, and that's not a big deal. It's more the case of one of the first things you do with performance testing is you typically don't load test the thing you're generating the load from, because the load generation can affect the results you get. Does that answer your question? Sorry.
Yeah, I guess also, do you test your production system directly, or during certain load periods?
We typically don't test production directly. We actually have pre-production systems for that. there may be a case where we take part of our production offline and then we'll load test it, but we typically don't load test it when it's online. We have users who can do that for us.
Accidentally load test.
Or yeah, sometimes we do accidentally load test things. Usually they survive, sometimes they don't. Any more questions to the right?
If you're not using database sharding or clustering or anything like that, how do you deal with violations?
Usually, we don't do database sharding, but we sort of do database sharding to effect in that we have lots of different databases, and that sort of, it's usually we would say shard maybe by type of record rather than actual sort of, having one set of data going over several things. The main thing there is, again, in most cases, we also do a little bit of MySQL replication. We are a MySQL shop, by the way. And that lets us split reads and writes a little bit, and that lets us wring a bit more performance out of it. Yeah. Down the front. So a bit of confession, we're still on Ruby 1.8. We are trying to move to 1.9. Hopefully, since Rails 4 is just around the corner, and they're dropping support for 1.8, that'll be a further kick up our rear end to get onto 1.9. Although now that 2 is just about out, maybe we'll just jump straight on to 2. We have had problems with garbage collection. Previously, I think one of the third or fourth slide I had our agent admin system, and I know we've had problems with that, with the garbage collection. If you look around, there are a lot of sort of patches and tunings for the 1.8 series. There's Ruby Enterprise Edition, which is mostly 1.8 compatible, and they've got a lot of the fixes that are now in 2 for garbage collection. Also, I think Twitter have their own patch for 1.8, which does a lot of things. In essence, most cases, the fix for garbage collection is you try to avoid running garbage collection in a request cycle, and you either... Yeah, that's right. To a certain point, you're basically just trying to turn off garbage collection for your request cycle and either run it when the passenger process is idle, or you kill your passenger processes periodically, and that's how you do garbage collection.
We had similar problems that we were thinking to try and, we couldn't, but we were thinking to try and find the bits that were actually causing the garbage collection. It's a little more expensive if you manage to send off-site some of the things that you can find as the
we did a little bit of digging. Unfortunately, some things in our code base are complicated because they need to be complicated. So that was sort of its case of diminishing returns, and unfortunately, it's a lot easier in cases just to tweak it and get a bit more memory or try to find. We found we could work around the problem faster that way than by fixing the code in question. Anyone else? Last chance? Oh, in the front. Yep.
That's all your legacy systems as well as Ruby systems?
That's sort of everything we use for the front-end websites, realestate.com.au, Real Commercial, and a few other bits and pieces. But that is sort of, there's other stuff in there. For example, we send out emails to people. There's listing administrations, there's our search indexes, databases. There's sort of, it's not just sort of one thing. And it's not just one large application either. There's several different code bases in there.
So did you put wrappers on your legacy stuff to talk to your new writers?
With certain qualifications, yes. We have a bunch of different systems. At the moment, we're slowly trying to sort of make it a more HTTP-oriented split. At the moment, we sort of have a fairly large sort of code base, and we're sort of trying to like cut that up into various slices and turn it into sort of smaller microservices, which are much easier to sort of manage. No, done. Finn?
Thank you very much.
Thank you.